Hello, good evening from Manila, and welcome to the first part of our webinar and masterclass on Open API architecture and product management. Thank you so much for those of you who are joining us. We have close to 100 attendees mostly from Southeast Asia, but registrants are more than 200 from around the world. So that's great to see the turnout and really appreciate the interest in this. So just a couple words on Brankas. My name is Todd Schweitzer. I'm the co-founder and CEO. In a minute, I'll be introducing Ken, who's my co-founder and the Chief Technology Officer at Brankas. So what Brankas is, what we aim to do is catalyze and bring some energy and infrastructure to what we see as the emerging open banking ecosystem in Southeast Asia. And what that means practically is we do a lot of work with financial institutions, our engineers and our product managers working with financial institutions in the nitty-gritty to help them build out the very beginnings of the open API and open banking infrastructure. And for those of you who are in Southeast Asia, you know that this isn't like the UK or Europe where there was a top-down mandate from the regulator. In Southeast Asia, the open banking, open API use cases that we're seeing in financial services are really being driven bottom up by smart digital banking heads realizing that there's a commercial opportunity. Fintechs, having increasing demand for banks, bank partnerships and providing bank services through APIs. And just more and more of the startup ecosystem where developers are expecting to be able to access and interact with fintech products through kind of more modern infrastructure. So on the one side, we work with banks to help them become API ready and open banking ready. And we have some proprietary technologies to help them really speed up that development. And on the other side, we do API aggregation. So allowing fintechs to more easily access and consume open banking API products in a much, much faster way. And typically that's actually a benefit to the bank because they don't have to focus on the last mile, SDKs and dashboards and documentation and all the sort of user-friendly stuff that makes it easier to consume bank APIs. So in this way, we're trying, at least making an attempt at building both sides of the ecosystem and making it easier for both banks and fintechs to collaborate. So our speaker today is my co-founder, CTO. Ken and I have known each other for almost 20 years now. So we actually went to a university together at UC, University of California, Irvine in Southern California in the US many years ago. Since then, Ken has been in Southeast Asia more than 15 years. He actually came out to Southeast Asia to be CTO of Multiply.com. Multiply, for those of you who are too young to know, was one of the early and largest e-commerce marketplaces in Southeast Asia. And really, Ken was instrumental in building out their infrastructure to support tens of millions of users across, I think, 10 different countries. And of course, scaling up their payments architecture, right, and integration with banks. Before then, he was the founder of a payments gateway in the early days of e-commerce, so managing a lot of the online payment methods and architecture to support those payment methods. So what I'm saying is Ken comes from a long background as a systems architect, but specifically focused on payments and banking architecture in particular. So I'm grateful, to have him as co-pilot for this, for Brankas, but also he has a lot of knowledge to share on what open banking architecture should look like, and kind of the good, the bad, and the ugly that we've seen working with banks across the region. Just a couple of housekeeping things. So this is scheduled for an hour and a half. I think Ken's presentation is supposed to be about an hour, and then we'll have open Q&A, but please, 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 use the Q&A button on the Zoom thing. Use the Q&A button to ask questions. I will be watching it, and I will try to jump in periodically when it's appropriate and relay your questions to Ken. So please, this session is for your benefit. So please ask questions. Please, even if whatever you think it's, you know, only slightly relevant, or if you know, think it may be a dumb question, there's plenty of newbies or you know, non-API experts on this webinar. So please ask questions. We will point those to Ken and make sure that you get your question answered. So anyway, you're not here to hear me talk. You're here for Ken. So Ken, over to you.
Thanks, Todd. By the way, I'm not able to start video for some reason. It says host has disabled it. Okay. All right, well, I did want to start my video, but I can't seem to be able to do that. Are you, Todd, are you able to see my screen now?
Yes, I can see your screen.
Okay. I'm concerned, though, that it is not showing the whole screen. Is the Brankas,
there you go. Yeah.
No, but is it open banking APIs at scale? Is that centered? Because I see a green outline that leads me to believe it's not sharing the entire screen.
It seems okay.
Okay. Oh, and hopefully video is working now. So.
Yep.
Okay. So is this cut off?
Yeah, it is. It is cut off.
All right.
Yeah, now it's good. Now it's okay. Now it's okay, Ken.
So it's full screen though. So you're seeing the whole thing. Okay.
Yes.
So yeah, so as Todd mentioned, I'm the CTO of Brankas. I'm formerly the CTO of Multiply.com, and my entire career has been in basically nothing but building payment processing and banking technology in Southeast Asia, North America, and also somewhat in Europe as well. Just to let you know, this presentation is not going to be overly technical, but I do come at this from a technical bent, and to kind of show my credentials as being an actual technologist. I do like to tout that I once ran a 1.5 petabyte MySQL cluster that was for Multiply, of course, and we ran a we were running something like 8,000 API requests per second on that system. So it's, if you're aware of kind of what that means in terms of like the load and how many servers and things of that nature, you would probably recognize pretty innately that 8,000 requests per second is, while that may not be a Google size number or a Facebook size number, it is a very, 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 very large number, significantly larger than probably most technology companies, especially here in Southeast Asia, are handling. So just kind of give you an overview of what I'm going to be discussing here, and to give you some background is I'm coming at this to talk about how APIs are used and adopted and how they can kind of be put into place in the infrastructure stacks of banks, and to basically share a specific client journey that Brankas had about 2.5 years ago, and to share with you about maybe some of the common problems that you're having if you're a bank, or even if you're just looking to kind of maybe adopt modern architectures such as microservices, or move towards non-monolithic architectures in general. So in late 2017, a very large tier 1 consumer bank in Southeast Asia came to Brankas, and they were looking to basically be the first in the market to provide open banking APIs to their users, to their clients. And they wanted to be able to provide kind of the typical open banking systems, which are, user account data, transactions, payment flows. They wanted to be able to do third-party wallets, e-commerce apps, etc. They were coming at this from a perspective that they saw this as there was already a race to get these technologies out and to accommodate the demands of advanced technology teams. For example, They were in 2017 talking about integrating their bank account data inside apps like Grab or Lazada or possibly some other companies that you might know of here in Southeast Asia. Like most large financial institutions, they had some very unique enterprise challenges, which is they had very legacy technology in place that was very monolithic in its design. There was literally nothing off the shelf that they could possibly adopt to really provide open banking solutions. And they needed to do this very fast because, as you may or may not be aware, when working with a large enterprise, any time that a project slips on a deadline or can't be completed quickly, you run the risk of it getting canceled or just not having the resources, either budget or human resources to get it done. At least not done correctly. So that's kind of one of these unique things that Brankas has been able to really be of assistance to with these large enterprises, is basically coming in and helping them get these projects done in a much quicker fashion than might be possible otherwise. So the bank came to us and their original architecture looked something like this. They had some monolithic systems. It's kind of hard to see, but they're in the gray background here on the screen, where their accounts, their statements, their reports, and their business intelligence were all kind of in a single application. And they had a bunch of connectors to back-end applications that they had to provide that provided core banking features to their branch applications or ATMs. And they simultaneously had a next generation application that was already making use of some internal services that were designed using SOAP, REST, ISO 8583. And they had two core banking systems, one built on AS400 and then another built on Oracle, that it was necessary to kind of accommodate in all of this. And they were looking basically to, how do we bring this old monolithic architecture into a kind of a new world perspective. And they wanted to do this. So let me explain some of what the problems or the challenges with that existing architecture was. It was a giant mismatch, quote unquote, generational technology, where what I mean by generational technology is that different generations of developers over more than a decade or possibly even 2 decades had come in and had layered on new technology that was completely unhomogeneous and completely basically really just was idiomatic of the generation and the time period in which it was originally designed. So, we were looking at early web services built in the late 1990s that were SOAP-based. They had some PHP-based stuff that were, non-idiomatic REST. They had physical transaction processing systems that were running, that were communicating 8583. And it was just really just a giant cauldron, and everything was just completely mismatched. There was multiple programming languages: Java, PHP, Node.js, and I think they maybe even had some C or C++ in there somewhere too. So it was just very, very old and rickety. They had very complex business rules and aggregation behavior that just could not be changed, which was a problem with their original architecture, which is that, if they took down their monolithic application or if they changed any of that behavior, they had literally thousands of branches that would lose access. And similarly, they had console-based applications that their staff were using, that it was just not realistic to retrain their many tens of thousands of branch staff on within the available time frame for this project, which was very short. So just to go back, this is the that original architecture, just to give you a very high-level overview of what it looked like. The gray pieces are the monolithic applications, essentially, and then the connectors that they had were the Gen 1, Gen 2, Gen 3, 85, 83 SOAP and REST connectors, just to give you an idea of what this kind of looks like. So we talked with them, and we came in as special consultants to essentially say, okay, this is what you are, this is where you are today, this is where you'd like to be, and how do we get you from essentially transform not just your technical processes, not just your technology, but also your internal processes, so that your teams can actually manage this giant monolithic system in a more efficient fashion. And one of the things that we had found is that they had a real challenge of getting a concept to an actual product. And they really wanted to retain the ability to do this internally and not have to continually rely on external or third-party systems. And one of the big things that they had is that the bank had a huge requirement that they needed to migrate their existing infrastructure, this existing monolithic system, to a services-based or a microservices-based architecture, but they wanted to do it in a way that would allow them to scale linearly, not exponentially, and be able to run this on a third-party cloud provider, because they simultaneously wanted to deprecate their old aging IBM mainframe systems. And what they basically had as a problem is that as this monolithic application continued to get larger and larger in the various functionality that it provided. So, for example, providing a connector for SOAP, or providing a connector for 85, 83, or these other things, is that the bigger this application got, is it basically started to hit the limits on the actual computing power that you could actually physically throw at the thing. Like, they just didn't have servers that were large enough, that had enough computing power or enough memory to actually run the core application anymore. And every time that they pushed out a new major release from their internal development team, they would basically have to upgrade to a newer physical machine, and they just were no longer seeing returns of adding bigger or more powerful or more expensive hardware because it just would not scale properly. Oops, I think sorry, I thought I think I am missing a slide. Oops. So basically, we came to them and we sat down and said, okay, first we need to transform your internal processes. If you're going to actually be able to manage a development team in a modern, running modern technology, you're going to have to match that with modern development practices. And they chose to implement an Agile Scrum development methodology, which we worked with them on to train their staff and to help them then break off small core teams so that they could actually work on breaking apart this huge monolith and creating standardized microservices. So the other thing that they had wanted to do, that they wanted to see as part of this, is that they wanted to see regular daily updates, and they wanted to be able to roll back code throughout this migration process. And they wanted to basically ensure that we had the lowest costs possible, and that they were adopting open source wherever we could. So these are kind of the solutions that we came to them with, which is adopt Agile, implement test-driven development, implement full end-to-end CI/CD pipelines, and use GitLab as their source control system. And oops, there is a notification here. And basically adopt other open source where possible on their CI/CD portion beyond GitLab. So, and then basically the other thing is that we helped to move them to standardized development, testing, staging, and production environments. And we worked with them to actually reflect this within their branching strategy on their new Git repos. Okay. Okay. After the bank was able to get a handle on how they actually handle this internal process of deploying code, they needed to then reconcile where the new services would live, which is, for them, it was a problem that they had a significant investment, a huge footprint with on-premise vSphere cluster. There was a large number of vanilla Dell HP servers, and they had simultaneously a new OpenStack cluster that they wanted to adopt as well. So we had these 3 generations of technology, 2 separate virtualization technologies, and they wanted to adopt all of this and make use of it in this new system. And the bank needed to leverage their existing investment while still having a cloud-style development workflow that also took into the account that they could scale horizontally, scale vertically, as well as then add new hardware or remove hardware to accommodate demand as it changed. Additionally, they needed to account for their standard depreciation cycles, and that would, I think, on a regular schedule of every 2 years, that they would, take out their old systems that were, 7, 8 years old, every 2 years, essentially, something like that. And then basically they were planning on eventually getting rid of all physical hardware. And so any system changes, anything that we did needed to be planned out so that we could eventually move it to a public cloud. They were tired of running hardware and decided, like how many other enterprises have, that it would just be easier to offload all of that work to a third-party provider, such as Google or Microsoft or Amazon or Alibaba or some other provider. So the solution that we proposed to them was to adopt Kubernetes as a single configuration and orchestration platform. That allows them basically then to adopt open source orchestration. They would have a clear migration path to Azure or AWS or GCP or some other system. And it standardized basically the deployments, and they're by essentially using something called containers, but was still basically flexible enough to essentially allow them, to create any kind of architecture they might come up with. And what's really nice about Kubernetes is that it allows them that way to very clearly and dynamically add or remove physical nodes to the cluster as the case may be. That is to either scale up the processing capability on a third-party cloud, or just simply when new, bare metal nodes are become available inside the data center, or as they get rid of it, as the case may be. So we then came to them about, talked to them, well, how do we then standardize your services? And they had a very clear necessity that through the generations of technology and communication, of RPC technology that they had used, whether you're talking about 8583, talking about SOAP or REST, they needed a very clear migration path for existing services and to basically get them into a modern services-based architecture using a standardized contract. And basically they needed to make sure that they could simultaneously provide existing functionality, but provide a path forward for new functionality. And they really wanted to standardize so that they could reduce and eliminate additional like code authoring, meaning like that they could use code generators and things of that nature.
Hey,
So,
Ken,
yes.
a couple questions that are relevant on this. So one is, how did your team help with actual API design? And then number two is, how much like context from the business side of the bank did you need to get in order to do this sort of architecture and API design?
Okay, so this actually kind of explains how we help them do API definitions. So what we did is, in designing APIs, is that we got them to standardize on using a technology called gRPC. What's nice about gRPC is that it uses something called protocol buffers for defining the actual API definitions. What we did with their team is that we sat down to define what the requirements were from a high level. And then one of our solution architects, basically me in this specific instance, sat down and translated those business requirements into an actual definition of service endpoints. So when we talk about APIs, typically they're organized in something called services, which are then a collection of endpoints, right? And that collection of services is then what you would call the actual API. So for example, let's say you have an open banking API, you might have a service, a set of services that are for accounts. You have a set of services for transactions. You might have a set of services for ATM locators or things of that nature. Basically, there are very standardized mechanisms not standardized mechanisms. There are very well understood and standardized ways to define APIs in what's called a REST style, which basically means that you have data that is at rest, and this is like the paradigm that's used for it, and you use standard HTTP verbs to essentially create, retrieve, update, or delete those terms mapped directly to HTTP verbs. And you use very standardized paths for those data entities. And if there is anything that is other than a create, retrieve, update, or delete, then it is an action, and you define that as a separate, via a separate mechanism, essentially. So for example, if you have a two-factor authentication flow, then there's a well understood way within doing REST-based services to essentially define that. Why we specifically advocate to clients to use gRPC is that gRPC has a one-to-one mapping with REST. Essentially, there are some places where it doesn't map correctly, but for the most part, it does a one-to-one mapping, and it basically provides you a path forward so that if there is some bigger or better technology that comes forward in the future, it will be very easy to migrate off from gRPC to that new definition in the future. And it does a very good job, for example, of being able to backfill on those back definitions. So for example, we've written generators that translate gRPC definitions that are in protocol buffer definitions to, for example, SOAP APIs. And we're able to essentially then expose the same APIs that are used for example SOAP, that were previously used for SOAP, but we can now define them using protocol buffers and essentially have a gRPC or REST service that implements that in exactly the same fashion. So that's kind of how we've done that. Todd, sorry, what was the second question?
Input from the business, and basically how much did you guys need to talk to the business side of the bank to get requirements in terms of API designs or definitions? And while I have you, there's another related question around API gateways. So there's a question of like, why Apogee? And then I'll ask a leading question, which is, does a bank necessarily need to choose a licensed product like Apogee, or are there open source alternatives?
Okay. So how much did we work with their team? So this was a very clear and straightforward, for this specific case study that I'm discussing here, for this specific client, we did not do a lot of interaction with the business team because there was no need to. It was very clear. We are deploying open banking APIs, and it's very well understood with the Brankas, developers, what that is, which is, for example, you have accounts, you have transactions, you have users, you have some other aspects. And what we're able to do basically is, and with this client that I'm referring to, is we basically went to them and we said, okay, here's the set of APIs that we can build for you. And you tell us which ones you want, how do you want to prioritize that, let us build a roadmap for you, and we can basically put these up and get them out there, get them out the door much faster. Getting back to your API gateway questions. So we were not the first vendor to come through the door on this project. We were the ones who were the primary developers. We built most of it. However, the bank that we're referring to had already been sold Apogee as an API gateway. And I'd like to point out that this specific case study that I'm referring to at the moment goes back to 2017. Since 2017, there's been a lot more progress on the open source side. And I don't know if today I would recommend, I don't think Apogee would be my first selection if I were choosing to build this from the ground up. But we were using Apogee simply because that was what we were, they already had a license for and we were making use of. For most intents and for most purposes, your API gateways don't matter too much in the grand scheme or architecture. The reason for that is that they more or less all solve the same fundamental technical problem, which is we need to be able to do auditing, logging, maybe some minor data translation from an internal service to an external service, or you want to do API query combinations, meaning that you've got one API call that maps to multiple API calls on the back end to different internal services. So all of your API gateways, whether you're talking about Kong or Tick or WSO2, I believe has an API gateway too as well. Regardless of what you're talking about, they all kind of do that. So for us, internally, we use an open source gateway called Traffic. And basically, we use a service mesh internally called Istio. So we recommended to this specific client to use Istio and then coupled that with their front-end Apogee installation, which they already had there. And then we suggested and got them to adopt gRPC for the actual services definition and implementation. Todd, what were the other questions about the API gateway? I'm not sure if I answered them all.
No, that's good. That's good. It's a question around why did the bank select Apogee, and are there alternatives, right? And let me.
There are many alternatives.
Yeah, and you mentioned that. So let me ask a question. This one's technical, so I'm just going to read it verbatim.
You said that gRPC is easy to standardize. Do you mean that the microservices serve gRPC, then gRPC gateway converts HTTP to gRPC? So the architecture would be Apogee to the gRPC gateway to the microservice. Is that correct?
No, that's not really correct. So gRPC actually is built on top of HTTP2. So without getting into the actual technical details of how all of these things work, what gRPC does is it allows you to define what's using something called an IDL, which is an interface definition language. You basically can define a service and then go and choose to implement that in whatever programming language that you want. This works really well for organizations that have multiple teams working on different programming languages. So for example, you can write a service definition in, you can just write the service definition. You can then write the consuming client in Java, but then the actual implementing service, that could be written in Go or PHP or Python or any other programming language that you want. What it does is it disentangles the client from the server. They don't have to be built in tandem. And when you're dealing with when you're dealing with large teams of developers, this is really the way to go, because Team A and Team B can basically come together and agree on how services talk and what the APIs do without either one ever implementing the client or the server. And that's very, very useful when you're dealing, when you're trying to build things quickly, because you can basically build to your specification and not build to random things, essentially, if that makes sense. What's really nice about gRPC, at least in this case, is I personally really like all of the functionality that is built into it. And it's because gRPC was designed specifically to have a one-to-one mapping with REST, using essentially what are annotations inside your protocol buffer definitions. It makes it very, very, very easy to enable the same service to be consumed by mobile apps, by web browsers, or anything else that you can imagine, whether you're talking about server-to-server implementations or whatever it might be. And as a developer, it's really great because you never have to touch the serialization or deserialization, meaning, you know, writing data to and from the wire or over a protocol like HTTP, because all of that is handled for you by the gRPC framework. Now, I've not called it gRPC framework previously because that framework is dependent on the programming language that you actually use. So when you're using a mobile browser, when you're writing a mobile app, you're going to be using a different gRPC framework to communicate with your backend that might be written in, let's say, Go. And Go has its own gRPC framework. It's not really the right name, but let's just call it frameworks, that implements the gRPC communication layer that allows the client to speak to the server. When we're talking about building super large systems that have microarchitecture designs, that have microservices as an architecture design, you might have, you know, hundreds or thousands of services. And what's great about that is that what's great about gRPC is, for those types of architectures, is that you standardize how those services are defined, and you standardize how the clients communicate with those front ends. And that front end, for example, probably in your architecture, if you're building a bank or if you're building some other large internet-based services, is going to go through something like an API gateway. And that's what's really nice. And yeah, sorry. Todd, were there other questions there?
Yeah, a couple more. So one is one very technical one around message buses, right? So did you use a message bus like Kafka or Nats to handle transaction queues? And how did you handle transaction rollbacks? And then the other one, which I think is really important, is an organizational question around working with the bank's internal tech team, right? So like, why didn't they do this themselves? Why did the leadership choose to work with an external partner? And like, what are your recommendations for working together with the bank's internal development team?
Okay. I really wasn't trying to talk about using message buses on this. We did use Kafka for one specific portion, but none of that is really related to this open banking API development that we did. The Kafka message bus that we used with this same client and that we've used with other clients was more about for processing incoming and outgoing logging messages than it was necessarily about processing transactional data. Specifically for this client, how did we do rollbacks? So it was built into the database. So they had a standard Oracle database, which was the master for their core banking. And most of the core banking functionality was built as stored procedures or a combination of stored procedures directly into the database. So the way that we broke out the monolithic architecture is that we basically decided on where the cut points were in the monolith. We then rewrote that same functionality. We then got the monolith to communicate to a new microservices that implemented that removed functionality. And then those microservices then spoke directly to the database, which is how we basically then changed how we basically were able to migrate from a monolith to a microservices. But there's a lot of detail in that we really don't have time tonight to go through. So that was the how to do rollbacks and the bus. What was the other question, Todd?
So like organizationally, I guess.
Oh, right. Why did they work with us? So
and why not just have a developer team in house to just build these out, right?
Right. So they did have their own developer team, but unfortunately, as this is a lot of times. Understand that a lot of the technology that they wanted to adopt was very cutting edge, and no one on staff at the time was familiar with kind of these web-based technologies or how to build open systems or open designs using modern technology at the time. And it was not necessarily that they weren't capable of doing it. It's more like their staff was working on other projects, so they had limited resources available, and they brought us in as an augment to their existing staff. And so we actually worked hand in hand with their developers on site to essentially build this out. We basically went in, I went in, designed a lot of the open banking services in gRPC. And then we tasked, let's say, okay, this bank's team will build this service. Our team, our Brankas team will build this service. And then once we did that, we then wired them all together using the service mesh and got everything communicating together and directly. But that's really more about. It wasn't that they didn't have the staff, it's just that they didn't have enough staff to get this done, or they didn't have staff that were necessarily up to date on it. And the way we built this is that we eventually turned this over to them, and today their staff is now running and operating it without any intervention from us. Okay.
So one more, Ken, actually 2 people asked pretty much the same question around how do you do API versioning with gRPC?
Okay. All right. So there's 2 ways basically in gRPC, and the way that I do it is that I define a so let's say if you have a V1 spec in gRPC and then you have a V2 spec. If the V2 spec, I only implement the APIs that are so the way you do it is that you can organize it either based on a directory structure where, let's say, all V1 definitions are inside the V1, and then you namespace that out so that each API call is something like v1.accounts or v2.accounts or whatever, just silly example. What you then do is then if where V2 differs from V1, then you either then write a V2 implementation and then have V1 translate that either from your API gateway on the front end to that call, or you just basically make sure that both implementations continue to work until some future time where the V1 is like completely and finally deprecated. One of the reasons also why I like using gRPC is that because it is a binary protocol, and one of the things that you have to do in your service definition is that every component of the request or the response object that gets sent back and forth between the client has to be given a dedicated numerical index. It allows you to maintain forward and backward compatibility very, very, very easily. But that's something that's unique to gRPC and not necessarily unique to API definitions in general. When dealing with API definitions in general, it's really best practice to just kind of, namespace it out and do that just as I said, which is maintain a V1 API and then maintain a V2 API. Or if you are starting from the point where you've never versioned your APIs, then you call your existing APIs based on whatever paths they are. Those are your V0 APIs. And then moving forward, you then start with a V1, V2, V3, or whatever kind of version. You can't really get around the fact that at some juncture you will probably need to maintain multiple versions of the same function call at some point, but that's just kind of a nature of it. But for the most part, it's nice that in gRPC it's fairly easy to version that. And as I said, the way that I do that is that on disk, literally I create a separate V1 directory and then a V2 directory for the versioned API calls, right? And then so the way that I do it is that V1 and V2 will never have any overlap whatsoever, including data entities or request or response objects. They will never ever overlap. They will always basically maintain a different version within your source repository. Now, they may share the implementation, but that's fairly easy to do because internally you can just call, you can either call forward or call backward depending on how your APIs have changed over time, right? If that makes sense. Okay. All right. Sorry, Todd, what was it?
No, you're good. Go ahead. Okay.
All right. So primarily it's very important, you know, when building out large API systems that you standardize, especially when you're talking about microservices. And for us and for our clients, you know, we just adopt gRPC. All right, moving on. So when talking about this bank that we rolled this out for, the bank realized at some juncture that it was not possible really to maintain 4 different back-end programming languages. Quite frankly, this fractured their development teams, and it meant that they couldn't easily move you know, developer from team A to team B, especially if they were using different programming languages or different technologies. And the other thing is that there are some programming languages like Java that are very, very notoriously very, very difficult to actually deploy in a container due to their computing requirements or memory requirements. And this also factors back to at the beginning of the discussion when I said that the original monolith core banking application was literally hitting the limits of how much computing power could be put on a node realistically. And when we talk about doing cloud native development, you know, what you tend to find is that you either have a ridiculous amount of computing power and you're short on memory, typically is what you tend to find in modern systems. So for example, you know, putting 100 gigs in a server basically will double or quadruple the price than it would to just basically double the amount of you know, computing nodes that actually exist. So for example, if you look at it, you know, I don't know what a Ryzen 3 high-level 64-core processor goes for, but I think it's something around $3,000. Whereas to put 100 gigs of RAM into that means that you have to have a beefier motherboard. You might be limited by what that is. If you don't have server motherboards, you might not be able to get more than 64 gigabytes into a system, et cetera. And one of the things when we talk about you know, wanting to do large-scale microservices-based architectures or large sets of APIs is that you're going to find that when using something like Java, you're going to really start hitting those memory problems. So for example, if you want to rely on something like, let's say, Elasticsearch on your backend for managing search, I believe the minimum memory requirements for Elasticsearch for a production environment that is like referred to as you know, the quote-unquote minimum by the actual Elastic company is 32 gigabytes. So there's a limit to how many of these you can actually start deploying. And specifically with our client, they had their monolith was basically written in Java. They did have some C components, as I had mentioned, but for the most part, because they were running Java, that really limited how, you know, where it could be run essentially. And that was a problem. So our solution for them was to basically write all new components, anything that was quote unquote new, write it in Go. I know that this might make me sound like a Google fanboy. I'm referring to, you know, gRPC and Go. But quite frankly, the reason why I recommend it is that Google has very much pioneered these large-scale microservices-based architectures, and they're very, very good at doing that. And Go is really probably the best, you know, cloud-native programming language that is out there because it's very simple to start working in it. It's about the same difficulty as PHP or Python, but you get all of the benefits of compiled programming languages like C or C++. which means that you can very easily and quickly integrate with C and C++ libraries. You can build a single static binary, and unlike Java, Go has very low memory requirements in general. Like typically, I don't see very large Go applications running on anything more than maybe 2 gigabytes or 3 gigabytes at a time. And if you're familiar with Kubernetes or containers, what this means is then if you're running multiple pods for your application, which is what you do when you have a microservices architecture, if let's say your physical nodes have 64 gigs of RAM or they have 32 gigs of RAM, you can get 16 different microservices running on a single physical node, whereas Java apps typically might require 16, 32 gigs. And so you're really looking at like requiring significantly less number of computing nodes in your cluster. Now, when we're talking about physical bare metal on-premise systems, that's not a big deal. But when you start deploying to third-party clouds like Amazon or AWS or GCP or Azure or whatever it might be, it really starts to add up, because let's say that on a bare metal cluster, I have a requirement that I need 4 physical nodes that have 32 gigabytes of RAM. I assure you, if I were to migrate that same system from a bare metal cluster, even using the same generation processors or whatever, I'm going to need 4 to 5 times as many nodes in that virtualized cluster, that managed Kubernetes cluster running on AWS or GCP than I would on bare metal. And that's something that I know it's not, cloud operators don't really like to talk about, because there's a lot more, they really like to pump up the benefits of scaling up and scaling down. But it really is the case that you're going to need 4 or 5 times as many, CPUs, or let's really say vCPUs, than you do on a real cluster. And that means typically that if you had, let's say, going back to Elasticsearch, let's say you had to have, for redundancy purposes, you had to have 2 Elasticsearch nodes, each requiring 32 gigs of RAM previously. Well, now you're going to need 6, 7, 8 nodes possibly on a cluster running on GCP or AWS. And that's really where you start to see your costs just kind of go through the roof. And this is why we recommend and decided to adopt Go for this specific bank, because they had the original requirement that while everything was on bare metal at the time, we're going to eventually migrate to a public cloud at some point in the future. And I believe today they now run our open APIs on a hybrid solution, where they're running some of the services on a cloud and some of the services on their bare metal cluster. Okay, so going back, this is just a refresher of what the application looked like. And what we had to come up for them is we needed to basically break out this architecture in a way that was able to deprecate old systems, extend the lifetime of existing components, but then simultaneously roll out new functionality while ensuring that the monolith continued to operate in order to service their thousands of branches that were out there. And so what we did with them is we worked with them to explode the monolith, to standardize microservices, so they could actually get scalability. They could actually go beyond their single one node or multi-node server that they had. They could migrate then their internal SOAP and REST endpoints of gRPC and basically give them time to build out a bigger system, as well as then create new functionality for their new system. So this is the architecture that we came up with. I like to point out that it's not really that much different, but what we did is that we broke apart the monolith into these separate microservices. So whereas before, So whereas before we had a single monolith running on this gray application where they had internal components that handled accounts and statements and other, core banking functionality. What we did is we then broke that out. Where is my mouse? Clear all drawings. We then broke that out into multiple microservices. So we broke that out into an identity microservice, an accounts microservices, a statements microservices, hidden behind an API gateway. And then we took their old generational PHP and Java internal APIs, SOAP APIs, etc., and we translated that into a standardized gRPC APIs that were then exposed as SOAP or 8583 or their old invalid REST stuff to the back end. And we then migrated their reports and BI stuff to directly on a separate system because we couldn't touch their reports and BI system and we deployed all of this on Kubernetes and rewrote all of those internal services, all of that internal functionality as internal services, and then exposed through standardized APIs. Now, their API gateway then allowed mobile apps as well as their online banking portal to then access that through standard REST-based APIs. Okay. All right. Oops. All right. So because we were able to do this, the bank was basically able to accomplish this migration in just 3 months, at least the first phase. They were now no longer bottlenecked with performance. They were able to really scale their APIs using this microservices architecture, and they really got greater density and use of their existing hardware through Kubernetes, which basically meant that their next refresh cycle was going to be significantly lower because it was less new hardware that they would have to purchase to replace the older or failing hardware. But what it really did primarily is that it really gave confidence to their existing internal business teams and development teams that by adhering to agile processes with consistent tooling and consistent management of the end-to-end software development, that they could push out new functionality in a much faster period of time. And now they're able to much faster, they're able to now really pilot new functionality in a way that they couldn't before by simply prototyping a new product or a new service, which so for example, after we accomplished the phase 1 migration, they then later wrote an internal loan origination system using the new services architecture. And they were able to do that very quickly because they had all of the APIs already well defined via service contracts. And so they could instantly make use of that and prototype things and get it out and deliver it to internal users in a significantly faster period of time. Separately, what they also did is that by breaking apart the monolith, they created very clear service boundaries that separated the logic layers that were originally within the monolith. For those of you who are developers on the call, that are actually familiar with managing large monoliths, one knows that you over time, the layers that may start off really nice inside the monolith, tend to get mixed up, right? And also by breaking apart the monolith, as I've mentioned before, we're able to really scale horizontally the systems, because now instead of ensuring that this entire monolith backend app had to run entirely on a single server, the separate microservices could be scaled up or scaled down accordingly. So, not all of the components needed, to basically be running on that massive server previously, right? So, for example, different components could be scaled, separately. So, for example, let's say you had an accounts microservice, and then you have your statements microservice. The accounts microservice might, need to run, might have 15 times the computing requirements, but the statements portion, might only need to run on 1 or 2 servers, but the accounts can be separated and scaled out horizontally in a much better way.
Hey, Ken?
So the other thing is that, sure, go ahead,
Hey,
Todd.
a couple ones. I think this is relevant for this anyway. So one is, someone wants clarification around, did the bank at all rewrite or ask Brankas to rewrite parts of the core banking system into microservices? And they're assuming that that would be pretty complicated, given that core banking is probably licensed by a vendor, right? And then the second question is around standard open API specs. So did Brankas follow a particular open banking API technical standard, or what was the approach there?
Okay. So for the bank that we're referring to, no, we did not have to license that. Their core banking system, they actually had 2 internal core banking systems. They had one built on Oracle, and they had one built on AS400. And it had been entirely internal development that had been done over the last 20-something years, essentially. So no, there was no licensing or need to work with a core banking vendor for this specific client. In the past, we have integrated our open banking APIs and our open banking layers on top of commercial off-the-shelf core banking solutions. So FIServe or others, Temenos, the list goes on. But in my experience, most banks probably have built their own core banking systems, especially the larger ones. The smaller banks tend to have maybe an off-the-shelf product or whatever, but quite frankly, what we've had to do to get our open banking standard out there. So we actually do have an open banking, an open source open banking API now. You can actually go to GitHub/openbank and download the API definitions that we have designed at Brankas. And those can theoretically be stood up in a number of minutes by your development team. There's no logic associated with it. You still would need to integrate that with your core banking system. But that may or may not be a challenge for your development team based on their capabilities. So specifically for this client, what we did at the time, we did not have our own open banking API standards. The standards that we have that we now push on GitHub is a new standard that was developed based on being informed by this bank client and a number of other bank clients into designing essentially a common or standardized API for open banking. But those are just the API definitions and not core banking logic or whatever it might be. Okay. Was
And one more.
Sure.
Yeah, that's and one more. So I noticed the microservices still share the same database instances. Did that impact agility to push out new functionality or performance?
No. So they had very large. Yeah. So as I had mentioned before, the vast majority of their core banking system was actually built on top of stored procedures in their Oracle database. And then they had direct AS400 queries. So it did not impact their database performance. It was still capable of whatever it was before. What we broke out was the monolith that was basically being used by their ATMs and their branch applications that had 8583 functionality and SOAP API calls. That's what we broke out so that it could make use of the same APIs on their mobile app and then on their web banking portal. But we didn't touch any of their Oracle or AS400 database. Okay. Was there another question, Todd? Or?
Yeah, there are a few more, but I know you have some more slides. I guess one general.
I only have a couple more slides. So.
Okay, so I'll ask this question because it's an important one, but maybe you want to answer it at the end. So basically, the question is like, how on earth did this bank accomplish migration in 3 months? Because that's like lightning fast for a bank, right? So I guess the bigger question is, you know, what would be your recommendations for a bank, particularly kind of large banks in Southeast Asia that are looking to launch an open banking platform? Like what are your kind of tips for a bank to launch this in less than, you know, in 3 months or less?
Right.
And where would the real bottlenecks be?
Right. Okay. So no, we did not completely rewrite every single aspect of the monolith in that time. What we did is we completed phase 1 within the first 3 months. And it was more about demonstrating to the client the speed by which modern development teams can actually operate with, you know, CI/CD, with adopting an agile methodology, and also then adopting modern technologies like Kubernetes and Go and gRPC. And for the first focus, we just broke out the accounts and the statements aspects, which were the problems that they were no longer able to scale. They couldn't scale their computing resources anymore for that specific functionality alone. But other functionality remained inside the monolith, and we mapped those API calls to that essentially. Now, over a larger period of time, I believe it was a total of 9 months, we were actually able to completely get off of that monolith and migrate all of the functionality from their old aging Java application to the monolith. But the answer to that is incremental, in an incremental fashion, right? So it's primarily, you know, if you undertake a project like this, like how does one go about doing it? You have to do it incrementally, and you have to do it in a way that you know, is automated, right? You have to eliminate human intervention as much as possible, which is one of the reasons why, for example, you know, we promote test-driven development. If you're not familiar with what that concept means, it means that you actually write your unit tests before you even write your logic. So, for example, we would write when we went through with this project, we broke apart. When we went through with this project of breaking apart this monolith, we first wrote unit tests to verify the behavior, you know, the inputs and the outputs before we ever wrote a single line of code that actually went to implement that. And that's what by putting that in place first, and with an automated CI/CD system, and very clear, development, testing, staging, and environment, and production environments, we were able to basically continually push out that code onto our Kubernetes cluster and basically verify that it worked at any given point in time. So the other thing is that when you are implementing a gRPC service, for example, it's very, very clear that the developer is either doing it right or not right, because a gRPC service, or a microservice, I should say, an endpoint implementation typically should not be more than maybe 10, 15 lines of code at the most. And you can see that when it's something like 10, 15 lines of code, a senior developer can come in and can evaluate that very quickly and be like, oh, well, this is going to do this does what it's supposed to do, or not. And they can literally read it and evaluate that, right? Much like if you were reading or evaluating, a macro implementation in Excel. And I'm sure a lot of you are chuckling at that, who have seen the crazy 30,000 line macros that are written in Excel at times. But fundamentally, it's kind of that same process of being able to go in and say, oh, well, with this microservice, let's say, represents this this lookup table in an Excel spreadsheet, and this microservice over here is this pivot table, and this microservice over here, translates from this pivot table to this lookup table, and then, collates that data over to this other place, and then you have this other microservice that is responsible for writing it. And it's kind of this Lego block functionality that one gets when putting together these microservices, which is really what allows you to rapidly iterate and push this kind of code out to production. Okay. All right. So this is the last slide, but basically what this now allows our bank client to do is that third parties or partners of the bank's internal IT teams can now pilot and innovate new services that leverage the exact same set of APIs. And as I mentioned, they later rolled out and built a loan origination system using those APIs that we wrote, as well as followed up with then deploying some new internal APIs for credit scoring and other aspects built on top of that. All right, and that's the entirety of the bulk of my presentation. So I'm happy to answer questions if there are more.
Cool. Thank you very much, Ken. And yeah, we have a few questions here, and please ask away for those in the audience. So one is just around data localization, right? So Indonesia has a requirement around local data storage. So how did this bank deal with that? Did they have to use GCP, which now has a data center in Jakarta? If you could share kind of how banks are dealing with, cloud migration versus local requirements.
Right. So the bank that I discussed tonight is an Indonesian bank, and they have everything on premise here in Indonesia. So data localization wasn't an issue for them. I
Okay.
think that they are thinking about using GCP now, but we aren't working with them actively on this at the moment.
Yeah. Okay. And then so generally speaking about open APIs and open banking, there was a question earlier around, is there an open API and blockchain solution that would allow for kind of better open banking products, or could blockchain aggrandize the architecture of open banking to support data protection of customers? I guess the bigger question is like, is there a role to play for decentralized ledger technology in supporting or underpinning open banking tech, or is it sort of, is open banking agnostic regardless of kind of choice of underlying database?
So we talk about open banking, we're really referring to kind of two parts, which is, you know, financial institutions, you know, providing access to their kind of legacy core banking systems, and then the adoption of that by, you know, let's say fintechs or merchants or other people out in the world. There's definitely room for core banking to integrate with at some point now or in the future with blockchain, you know, distributed ledgers of some kind. I don't think that there is really any bank that is seriously or actively pursuing that today. I could be wrong or mistaken about that. Separately, a separate issue of if you want to get into a philosophical discussion about does it make sense for individuals or the people who are not financial institutions to have, you know, to try to circumvent or go around banks by using some kind of different distributed ledger or blockchain or something like that. I mean, that's really more of a philosophy discussion than it is necessarily about a technical one. I see that there's a room or, you know, maybe a way in the future for that to be, you know, to happen. But short of support by governments in general that, hey, this is, you know, this is the blockchain. I don't know how you could possibly get everyone to settle on one core core distributed ledger or one core blockchain solution. Otherwise, you're just going to have Bitcoin today, Ethereum tomorrow, Monero 4 weeks from now, or something else that's going to be like the prominent one, you know, Ripple or blah, 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 blah. I mean, the list just goes on and on and on. I mean, anyone can start a blockchain in a matter of minutes, right? So it goes. Yeah, okay. Yeah.
Okay.
Is there other questions?
Another question. So just on this migration, right? Was this a big bang sort of monolith switch over to microservices all at once? Or did the team phase the approach and have microservices and the monolith running side by side for a period of time?
It was phased. They ran the monolith next to the microservices until, and basically, there was a very short period of time where we ran, we did basically double input and double output captures, meaning that we had the microservices live sitting next to the monolith, and we verified the inputs and the outputs from the monolith to make sure that the microservices were returning the same responses. And until we were actually comfortable with the microservices that, like, i.e., you know, 100% of the time they were returning exactly the same data or the same output based on the same input, we didn't switch over, right? Yeah.
Got it, thanks. The next question I don't quite understand, but let me try and convey it. So I think for this person, their internal banking system is using IBM Data Power 6, 7, or 8, and maybe RPGLE or SQL RPLGLE, RPGLE. Does internal banking apply some kind of adapter to connect to Open API, even though it's still using the old core banking system? Do you follow that question?
Yeah, so the bank I discussed here tonight had their own core banking solution, right? Other banks that we've worked with, you know, have different core banking solutions, and our company now has an off-the-shelf open banking platform that basically can sit in front of any core banking system. And what we discussed here tonight is actually the kind of the what's the word? The original reason why we built our open banking platform was to essentially sit on top of these legacy core banking systems. So we actually do have a bank client that uses data power, and so for that specific instance, we actually already have integrated with data power in a different, you know, probably in a different country than where you are. How that said, you know, I believe with that specific implementation, our open banking platform, the API definitions of which are open source and are on github.com/openbank, basically, you know, required some very heavy and custom integration to their backend. But I personally was not involved with that, so it's difficult for me to describe, to speak about that on a technical level. So no,
Okay.
I see an anonymous question here about REST APIs. Did we get rid of REST APIs entirely and move to gRPC? No. gRPC is only used internally. The external APIs are all REST-based. So as I had mentioned, gRPC has a one-to-one mapping to REST, which makes it very useful. So any public or external facing systems are using REST and are not, and gRPC is not enabled externally. So were there downtimes for every compute resource resizing? No. It is possible to, is there a reason why questions appear and then disappear in this talk?
They go, I think they were answered, so they move to the answered column.
I see. Okay. Were there downtimes for every compute resource resizing? No. We purposely, we really try to avoid downtime in any kind of capacity. There are definitely times when downtime has been necessary. Usually on the first, maybe the first rollout when you break apart a monolith, but it's really on a case-by-case basis. And we did not have downtime for this specific issue, no. Are there regulatory restrictions to move the solution to cloud? That depends on the country, but probably, absolutely, yes. One of the things that why I advocate, targeting Kubernetes and not targeting, let's say, a cloud provider is that it allows the ability to later migrate to a public cloud, such as Google or Amazon or Azure, but running bare metal Kubernetes is actually very easy and not hard at all. And it's much easier to have different divisions or teams of people that are allocated certain fixed resources or their own Kubernetes cluster, for example, with Kubernetes, than it is necessarily to allow them to have access to your OpenStack cluster or your vSphere cluster or whatever it might be. What was the challenge on applying Kubernetes into the banking microservices? So the real problem with when we did our bare metal Kubernetes deployment is that, as I had mentioned, we had 3 generations of technology of physical server that we had to integrate. So we had a we had a vSphere ESXi cluster. That's a VMware technology. And we had an OpenStack cluster that was, I think, supplied by Red Hat. And then we had physical servers that we needed to use as well, that were just regular Dell and HP servers. And so the challenge there is that when we were deploying bare metal, we had to deploy virtualized and bare metal nodes on that. And that meant that it became a little bit challenging predicting what the performance would be on those individual nodes. But that's one of the nice things about Kubernetes, is that once you get your physical node or your virtual node into that cluster, you can just treat everything the same. And then when you go to then later deploy microservices, you can scale them up very readily or easily, or pin them to a specific node, or for example. So for example, we were running there were some components where we had to run Elasticsearch on Kubernetes. I talked a little bit about Elasticsearch on that. We did actually need to use that for this deployment, not really related to this, but because it was for something else. And so, what's really nice is that you're able to deploy and pin microservices to specific instances when you do need that one physical node that has that 128 gigs of RAM or whatever it might be. Can you talk a little bit more regarding deployment pipeline, build, test, provision a new binary to the clusters via rolling out, etc.? So the way that we typically run, the way that we typically build those systems is that we have 4 standard environments. That's development, testing, staging, production. Okay. So when we build a service, a microservice, we almost exclusively use Go. And I guess when you say provision new binary, I guess you mean the application, not really a binary. How do we roll it out? So we build an image locally, okay, and then we push that to an internal container registry. All right. So Kubernetes is a container-based orchestration platform, and it specifically uses Docker for its containers. So you use a container registry, i.e. what Docker is, what the Docker hub is, but we have a private one on that. So we would basically, every commit that we rolled out would get allocated with a number. So v1.6.5 hyphen, and then we would use like the short hash of the commit, which would be, A, B, C, D, E, F, whatever might be the short commit. That would get pushed out to the container registry, and then on your deployment configuration, so on Kubernetes, there's a concept called deployments, okay? And that actually allows you to select the version of your image. And you can then select the number of pods that it runs on that deployment, and you can couple that with, for example, a service, an inbound service. That's another concept in Kubernetes, okay? What you do is we would just, change that deployment and then push that to the Kubernetes cluster, and then Kubernetes itself handles that actual rollout. All right. I hope that understands that in terms of the deployment pipeline. So what we would do is we would roll that out automatically to the staging environment on a regular, like with every single commit. We would then manually test. And once that passed manual test and smoke test using humans to actually verify that it was working, in addition to then checking error logs, et cetera, on staging, we would then manually change that configuration, and it would automatically go out to production. Okay. I hope that answers that. All right. What is the architecture that you use when building microservices like DDD or hexagonal architecture? How did you handle protobuf file for client and server? Okay, so microservice architecture, we did not have like an architecture for the microservices specifically. You would just call it like a pyramidal architecture, but there was no, we didn't do any kind of like hexagonal architecture or anything like that. It was just very top-down approach, because please keep in mind we were trying to replace a monolith. So the monolith originally had an internal, tiered architecture essentially, and we identified the cut points from inside that architecture, and then just rewrote those specific components as microservices, etc. How did we handle the protobuf definitions? So internally, we have our own developed standard called Gunk. It's based off of Go, so it uses the same syntax as Go. It's an IDL essentially that works the same way as protobuf, and we just store that in a Git repository. It's just a text file. It sits. The way that we manage it is that it just sits literally in line with the actual service implementation. So we would have a Gunk file sitting right next to a Go microservice implementation. And that's how we do that. Okay. Are there other questions?
No, I think we're up and we're a bit over time, but no, Ken, I think that was really useful, and I appreciate all the questions from the audience. So thank you so much for attending, and Ken for presenting. And please get in touch with Brankas. We're happy to help and discuss, especially for those in the audience who are coming from banks. If you're working through some of these problems, I know there's a lot of interest with the COVID situation on building kind of more easily scalable digital capabilities. So Brankas is happy to help out one way or another there. All right, thanks everyone. Please attend tomorrow. We have Mike, who's our Chief Product Officer, who will be presenting kind of the product management side of API development for financial services. So that'll be really interesting as well. Please sign up, and we'll see you then. Thanks so much. Thanks everyone.